Hello, this is John from caveofprogramming.com. Before we go on to look at reading and writing binary files in C++, we're going to just look at struct packing or padding in this tutorial because in the video on reading and writing binary files, I want to show you how to write a struct to a binary file. But before we do that, there's something important that we need to know about structs. And I'm going to return to this a bit later on in the project at the end of this course. So let's create a struct here suitable for writing to a file. I'll call it person. So the only difference between a struct and a class is that the members of a struct are public by default. And structs are quite often used for writing to files because let's say you have a binary file. It has a bunch of bytes in it. That all of the bytes have a different meaning, and what we can do is we can map those bytes to one or more structs directly to the members of structs. So I'm going to give this struct some data. Now I want to give it a name, but if I type string name here, there's going to be a problem because the string class actually. The string class, the objects of the string class, I should say, try to find the right way to put this, contain pointers. And when you actually get a string to store some text, that text is not stored directly in this variable here. When we declare variables in C++, they're stored on an area of memory known as a stack. This is a relatively small area of memory that's used for storing local variables and for keeping track of function calls. But because the string class doesn't know how much text you're going to want to store, it doesn't store text kind of directly in this variable in some kind of a way. What it does is it has a pointer inside it, and it uses new with that pointer to allocate some memory on the heap. And a heap is this much bigger area of memory, which is where you get memory from with the new operator. It's basically most of the RAM available to your program. So if we actually wrote this now directly to a binary file, we're not going to be actually writing the text it contains. We're only going to write a pointer to that text. And if we then read that pointer with a different copy of this program, it's going to read a pointer address that no longer points anywhere. So the bottom line is we can't use string because it allocates extra memory to store the actual text. So we by writing the string objects, we're not storing the actual text that they store for us because that's stored somewhere else. So what I'll do instead is I'll use a char. I'll arbitrarily say that I'm going to have a char array of, let's say, maybe 50 characters. So our name that we store is going to be 50 characters maximum. Let's also have a int age and double weight, just to have a few different types in there. Now, if we wanted to write this to a file, we've already got a problem because C++ actually pads structs to make it more efficient to transfer them to and from memory. So we can demonstrate that if we do, let's do a cout size of person here, endl. I usually say endler, but someone pointed out to me that endl is probably a more common way of pronouncing it, although programmers do say all kinds of things, so maybe endl is indeed better, really. So now if we take a look at this, let's see how many bytes it is. It is 64 bytes, but our int is 4 bytes and our double is 8 bytes. So 8 plus 4 equals, I believe, 12, and added to 50 is going to give us 62. And if you want, you can output the sizes of these and check that for yourself. We've got 2 bytes extra from here somewhere, and that becomes even clearer if we just add a single char onto the beginning, because we know that these definitely have even numbers of bytes in them, and this is 50, an even number. So we should, adding 1 byte on there, we should get an odd number, but we still get 64, exactly the same as before. And that's because of the padding that's done to make this struct more efficient to work with. If we're going to literally take this data and write it to a file, we need to turn off that padding so that what we write to the file is actually exactly what you see here. It's just this data stored, 1 byte after another directly. And to do that, we can use a preprocessor directive, and that is the pragma directive. We need to say pragma pack. And here we can say, there are various things we could type here basically, but I'm going to say push, 1. This directive has kind of like a stack-like structure. I don't use it very often, so I'm not very familiar with it. But if you think of a stack of cards, you can push cards onto the top of that stack, like playing cards, and you can pop them off the top of the stack. So here we're kind of pushing a directive onto the top of some stack. And what we're doing by saying 1 is we're saying align the data in whatever follows on single byte boundaries. Because if we align it on, boundaries of 10 bytes or something, or even potentially 2 bytes, then we're potentially going to get padding in this struct, which we don't want. So to see that makes a difference, notice that it says 64 for the size of the struct at the moment. And if we run this now, we get 62, which is what it should be. So now we've got rid of the padding. If you want to undo this directive so that it doesn't apply to everything you type after it, we can type here pragma pack brackets pop. And if we run that, we'll see that we go back to 64 for the size of the struct. So what we really want to do is surround the struct with this. So here we turn off packing, or rather we make the packing align on byte boundaries, which is the same as no packing basically. And here we turn it on again for the sake of efficiency. And now if we do that, we've got a struct that's exactly 62 bytes. And we can now write this non-padded struct directly to a file. We can write these bytes directly to a file, and then our program could read them again, either another copy of this program or even the same program at a different time. And what we're going to do in the next tutorial is, just for demonstration purposes, I'm going to fill this with some data, write it directly to a file, and then just read it again. So until next time, happy coding.